welcome to Unit 4, Analytical Trigonometry. We're going to talk about solving trigonometric equations. This is going to be a multi-part lesson because these problems kind of range in difficulty. So we're going to start off with some easy and medium ones and move on to some harder ones in a later video. All right, so let's first talk about solving trig equations. So a trig equation obviously has at least one trigonometric function. I mean, you can't call it a trig equation if there's not a cosine, a tangent, a sine, a cosecant, a secant, or cotangent somewhere in there. And there's obviously have to have an equal sign. I mean, equations all have equal signs. So here's three really good examples of some very simple, basic trig equations. Notice that all three examples have an equal sign, first and foremost, and they all have a trig function. Now, remember we're solving for the variable, right? That's what solving means. When you solve for an equation, you're solving for the variable. And in trigonometry, the variable represents an angle. Call it what you want. Call it theta, x, alpha, beta, I don't really care. In these examples, it's called theta. But again, we're solving for that angle. So again, we're solving for an angle. Think about an angle. Now, these problems really do range in difficulty. There are easy ones, medium ones, and hard ones. It all kind of depends. All problems are easier if there's only one trig function. Let me just say that. If there's only one trig function, they're going to be fairly simple. But if you have a secant, a cosine, and a cotangent all in the same problem, you might have to use the identities to somehow make it easier or simpler. You're going to have to do some work before you can even begin the solving process. And that is going to create a little bit of a medium or a harder level problem. But again, the easy ones have one single trig function that makes it pretty easy to solve for. So let's talk a little bit more about how to solve a trig equation. We're going to start off with this really, really simple one. Cosine of theta equals 1/2. Now, the most important thing you understand after this particular slide is that the answers are limitless. There are many, many infinite solutions to trigonometric equations. Because with a unit circle, you can go around and around and around and around and around as many times as you want. Angles have no limits. So that makes it kind of hard. But let's explore this one, right? So this is basically saying, hey, cosine of theta equals 1/2, which means we're trying to find an angle where the cosine value is 1/2. Okay, we're trying to find an angle where the cosine value is 1/2. Well, I hope you understand through our previous lessons and units that the cosine of an angle represents the x-coordinate, where that angle stopped. So I'm thinking x-coordinates here. So I'm trying to find an angle where the x-coordinate is 1/2. And if I'm looking, I see that happen right here. Now this brings up another good point. Do I want 60 degrees or do I want pi over 3? So read your directions, please, so that you know if you need an answer in radians or an answer in degrees. I'm a radian kind of guy. In fact, I say I'm a rad kind of guy. Pretty rad. So I would like answers in radians. So one particular answer is pi over 3. But again, if I add 2 pi, add 2 pi, add 2 pi, add 2 pi, every time I add 2 pi, I really get more and more and more answers. Because any angle that stops right here at pi over 3 is going to have an x-coordinate of 1/2, which means it's going to be an answer to this equation. But don't stop there, because there's another answer if we keep looking right here at 5 pi over 3. So another answer on the unit circle that I could see is 5 pi over 3. Now that means any angle that stops right here is going to have an x-coordinate of 1/2. Again, so what I have to think about here is the fact that if I add around and around and around, I can add 2 pi as many times as I want, or I can even go backwards, right? This would be equivalent to negative pi over 3. If this is positive pi over 3, this would be negative pi over 3. But that just means that negative pi over 3 is coterminal to 5 pi over 3. So it's, again, another angle that ends right here where the x-coordinate on the unit circle is 1/2. So here are two answers that I can visually see on the unit circle, but it doesn't mean that those are the only answers. So do I give all the answers? I mean, how do I write a solution if there's infinite answers? Well, okay, this is what we got to make sure we read the directions. If a question asks for all solutions, then yes, you do have to give all solutions. But obviously, it's impossible to write down an infinite number of solutions. This is where we use our brain. We say, well, we know theta equals pi over 3, but if we add or subtract 2 pi as many times as we want, we will get another answer. So this n is just saying that, hey, you could add 2 pi once, you could add 2 pi twice, you could add 2 pi 3 times, or you could subtract 2 pi one time, you could subtract 2 pi. So that n is just saying, hey, that there are multiple solutions because every time you go around a full circle, you got yourself another answer. And then the other thing I'm going to have to do is, again, 5 pi over 3 technically is a different answer. It's a different angle on the unit circle. So once again, I could take 5 pi over 3, I could add or I could subtract 2 pi as many times as I want. As many times as I want is where that n comes in. So if you do, or if I or a problem does say that it wants all solutions, you do need to include this additional 2 pi n to represent the fact that you could take the answer visible on the unit circle and keep going and going and going and getting more and more answers. But I will say this, most of the time, I just ask for answers on the unit circle, which in degrees is 0 to 360, or in radians is 0 to 2 pi. So if I say, listen, I know there's many answers, but only give me answers that you could see on one full positive rotation. So if that's the directions, then the only acceptable answers are pi over 3 and 5 pi over 3. Now, even though negative pi over 3 is coterminal to 5 pi over 3, it's negative. And if this is the interval that I want your answers in, don't give me a negative because this only includes positive numbers 0 to 2 pi. Or if you're using decimals, which is okay if it's an angle you don't recognize, which we'll talk about shortly, 2 pi is 6.28, just so you know. All right, so that's it, right? That's the idea, is that you're going to use your unit circle a ton to find your answers. But again, there's many answers. So read the directions. I will say for the rest of the problems in this video, I make it easy by only wanting answers from 0 to 2 pi on the unit circle. But if I do ask for all answers, you do need to add and subtract the 2 pi n to represent that you could just find a whole bunch more. All right, so let's get into the official part 1 of this video, which is looking at some easy problems. Remember, easy problems have one trig function. So here are the 3 problems I mentioned earlier. And again, we're looking for answers in radians 0 to 2 pi. So we've actually already explored this first problem. I'll pull up the unit circle again to look at. Again, we're looking where is the x-coordinate 1/2, pi over 3, and 5 pi over 3. So those would be my 2 answers. You can write them separately, or I'm okay with the comma, 5 pi over 3. You could also use the squiggly brackets to show that there's multiple answers inside of the squiggly brackets, or you could just list them individually. There's the first answer, and then here is the second answer. Either way works for me. All right, let's tackle this next one. Where is tangent negative radical 3? Now again, this is something I recognize from the unit circle, so where is tangent negative radical 3? Now, if you've listened to some of my suggestions over the past couple weeks, I highly suggesting on your unit circle cheat sheet, putting the tangent values as you go around the unit circle. That way you don't have to spend as much time trying to figure out where the heck is tangent negative radical 3. But I will tell you it's not in quadrant 1, because in quadrant 1, tangents are positive. It's not in quadrant 3, because in quadrant 3, tangents are negative. So if I look in quadrant 2, tangent is negative radical 3 at 2 pi over 3. If I take the y divided by the x, I get 2 pi over 3. But the cool thing about tangent is tangent repeats itself every half circle. So if I come exactly 1/2 circle away, I get 5 pi over 3. And tangent of 5 pi over 3 is also negative radical 3. So I get 2 answers here, 2 pi over 3 and 5 pi over 3. Those are the 2 answers in the unit circle where I see a tangent value of negative radical 3. And again, if I'm only asking for answers in that unit circle, those are the only ones you need to list. All right, next up, sine of theta equals 0. Now remember, sine is the y coordinate from the unit circle. So what I'm doing is I'm looking for y coordinates of 0. Where do I see a y coordinate of 0? Well, I see it happen at 0 and pi. Now, technically, it also happens at 2 pi, right? Because 2 pi is coterminal to 0. But notice, look at what I wrote here. Look at what I wrote right here. I wrote less than or equal to 0. And then, oh my gosh, I just realized I have a mistake here. That should not be or equal to sign right there. Because 0 and 2 pi are exactly the same. So my answers, I'm sorry for that. I can't believe I did that. My answers are 0 and pi. Now again, that's because I want answers on the unit circle starting at 0 and going to 2 pi, but including 0, not the 2 pi, because again, 2 pi is really just coterminal to 0 radians. All right, so those are really, really simple ones. And again, those are really simple ones that we recognize these numbers from the unit circle, so it doesn't really take a whole lot of work. All right, now let's look at some ones that are, again, still simple. Why are these simple? Because they only involve one trig function. But why are these going to involve a little bit more thought? Because these are not values that I readily recognize from the unit circle. So for example, this first one says cosine is 1/4. Now, I know that cosine is the x-coordinate, but if I'm looking at my unit circle, I don't have it labeled. I don't have an x value of 1/4 labeled. Now, it's on here somewhere. I mean, 0.25, 1/4 is somewhere right around here. I mean, it's somewhere in quadrant 1 or quadrant 4. In fact, you know what I say is in trigonometry, a picture is not worth 100 words. A picture is worth 1,000 bazillion quadrillion words. So draw a quick little miniature unit circle. Now, where is an x value of 0.25? It's going to happen right about here, right? About a quarter of the way to 1. Remember, this is 1. So again, this point right here, that is this angle. That angle right there is going to have an x-coordinate of 0.25. But so is this angle right here down in quadrant 4. See, that's the one thing these 2 points have in common is they both have an x value of 1/4. So I'm looking for these 2 angles. I'm looking for this first angle that goes into quadrant 1, and then I'm looking for this other angle that goes all the way into quadrant 4. All right, so how do I find this? Well, I'm going to pull the old switcheroo. I'm going to do an inverse cosine of 1/4 equals my angle. This is going to allow me to use my calculator to help me find my answers. Because again, these aren't going to be nice, simple angles that we recognize from the unit circle. Now, the only thing I got to be careful of is when I go to my calculator, your calculator is only allowed to give one answer. And again, that's why the picture is needed. Because when you go to your calculator, now hold on a minute, make sure you're in radian mode. Because I did ask for the answer in radians. If you put in degree mode, you're going to get the answer in degrees, and I certainly don't want that. So make sure that the mode you're in matters here. I want to be in radian mode. So when I go do the inverse cosine of 1/4, it's only going to give me one answer. Now, I need to be smart. I need to use that answer to help me, but I have to understand it might not be the only answer. All right, so I get 1.32 radians. So that's going to be the green angle. The green angle right there, that is in quadrant 1. So that's going to be the angle 1.32 radians. That's a good answer. I like that answer. And I can check my answer on that by just typing in cosine of 1.32. And voila, 0.25. Now you might be like, that's not 0.25. Okay, it's close. If I round it, it is 0.25. The reason why it's not exact is because I rounded the 1.32. In fact, if you want to be exact, let's just do cosine and let's grab all those decimals. And then look, now I get something that is it's still not exact, but it's much closer to exactly 0.25. But again, for the sake of putting your answer down, I'm okay with 2 decimals. But again, you have to know that that's not the only answer. So how do you find the other answer? Boy, you got to use your brain. Now, the other answer is the one in blue. Now, but there's where I got to think about symmetry. If that green angle is 1.32, this angle right here is negative 1.32. And again, just confirm that real quick. Cosine of negative 1.32, again, pretty close to 0.25. But I don't want any negative answers. I asked for only answers from 0 to positive 6.28, which is 2 pi. So I don't want that answer either. So I want to find the answer that's coterminal to negative 1.32. So I'm going to take the negative 1.32 that I clearly understand as my answer, but I'm going to add a full circle to get the positive coterminal angle, which is 4.96. So there is my second solution in quadrant 4. Now again, to confirm that's right, do cosine of 4.96. And again, not exact, but pretty close to 0.25. If you want to be closer, use more decimals. So again, picture's worth 1,000 words. It really helps. All right, let's do this next one. Same scenario. Sine is a y coordinate from the unit circle. If I look on my unit circle, I certainly don't see any negative 0.84s, or negative 0.85, sorry. So again, draw a picture. Pictures are worth 1,000 bazillion words. So a y coordinate of negative 0.85 is going to be down here somewhere. Again, it's a y coordinate, so I'm on the y-axis, and it's negative, and it's almost down to negative 1 there at the bottom. So that means there's 2 answers. There's this angle over here that's going to have that y coordinate, and there's this angle over here in quadrant 4 that's going to have that same y coordinate. So I need to find the blue angle that goes into quadrant 3, and then I need to find this gray angle that goes all the way into quadrant 4. Now, I can't use my unit circle, gonna have to go to my calculator. Make sure you're in radian mode, do an inverse, pull the old switcheroo. The inverse of negative 0.85 is negative 1.02. So I'm going to write that down, negative 1.02. But right away I realize that's not an answer I want to give because that's a negative answer. I clearly want answers from 0 to 6.28 positive. But that is going to help me find my answer. That negative 1.02 is this negative angle that goes to this gray angle. It's coterminal, right? So it's not the answer I want to give, even though it is in the right spot. So what I want to do is I have to add 2 pi to that to get the positive angle that is coterminal to it. So I'm going to take that negative 1.02. I'm going to add 2 pi, and I get 5.26. That's an answer I want to give because it's positive and it falls into quadrant 4 there. And again, take a quick, it only takes a second to check your work. Sine of 5.26, again, it's not exact because of rounding, but it's pretty darn close to negative 0.85. Now, how do I find this blue angle that goes into quadrant 3? Well, once again, we got to think about symmetry here. If this angle right here is 1.02, then so is this angle right here. So now, to find that blue angle in quadrant 3, I'm going to take a half a circle pi. A pi is half a circle. And I'm going to add that extra 1.02 that's going to get me to where I want to go. So again, now I'm going to take pi plus the 1.02, and I get 4.16. Again, why not take a second to do sine of 4.16 to confirm that we get something, again, not exact because of rounding, but pretty darn close to negative 0.85. So my second answer is positive 4.16. So you got to be super careful when you're using your calculator. You just got to have a brain on your shoulders. Well, not on your brain doesn't sit on your shoulder. Your brain's in your head, which is in your, okay, you get the idea. All right, let's do this next one. Now, tangent's even trickier, right? Tangent's even harder because it's not x, it's not y, it's a ratio of y divided by x. So it's kind of hard to figure out exactly where it's at, but it is positive. And I know that tangent is positive in quadrant 1, and then directly 1 circle away in quadrant 3. So even though this might not be the best picture of where tangent is 24, at least I know for sure since it's positive, I'm in quadrant 1, that green angle, or I'm all the way around in quadrant 3. Regardless, drawing that picture helps see where those 2 angles are. All right, so now what I'm going to do is I'm going to go ahead and pull the old switcheroo using an inverse tangent. Make sure you're in radian mode. Inverse tangent of 24 gives me 1.53. And again, why not just type in tangent of 1.53 real quick just to confirm, yeah, I get something really close to 24. Again, if you really want to be more accurate, use more decimals. All right, so one answer is 1.53. That's going to be that answer with the green arrow that ends in quadrant 1. But now I want the answer that's in quadrant 3. So here's my thought process. Tangent, here's my thought process. Tangent repeats itself every half circle exactly. So essentially I just got to add pi to my answer. But if you want me to really kind of explain that to you, think about symmetry. If this green angle right here is 1.53, so is this angle right here. So if I take a half circle, pi, add the 1.53, I'll get that green angle in quadrant 3 that I want. So I'm going to take the 1.53, and then I'm going to add pi, and I get 4.67. Real quick, it doesn't take any time to just briefly check. Yep, pretty darn close. Not exact because of rounding, but pretty close to 24. So my second answer is 4.67. All right, so notice that if you have a sine, a cosine, or tangent problem, the thought process is a little different. So that's why you really, really, really need to understand what you're doing and use that calculator properly. All right, now let's jump to some more problems here. How do you solve if there's a secant, a cosecant, or a cotangent, right? We just did a couple problems with sines and cosines and tangents. What about if you see the reciprocals? Well, don't panic. Reciprocate. So for example, if I see a problem with secant, I think, oh boy, I don't like secant that much. No big deal. You are more than welcome to use cosine as long as you take the reciprocal -1/2. remember, secant and cosine are reciprocals of each other. So if I know secant's -2, I automatically know cosine is -1/2. Now I don't have to worry about a secant. I have to worry about cosine, which is an x-coordinate. Now, 1/2 is something I recognize very easily. So if I look on my unit circle, where do I see an x-coordinate of -1/2? I see it at 2 pi over 3 and 4 pi over 3. So there's my two answers, 2 pi over 3, and I should use a theta, not an x. It doesn't really matter. And 4 pi over 3. How simple was that? Awesome. All right, what about this next one here? Cosecant. Oh, I don't like cosecant. Okay, I like sine. That's the reciprocal. So again, if cosecant is negative radical 2, sine is -1 over radical 2. Now, you might not recognize that, but if you rationalize the denominator, you will. This is negative radical 2 over 2, which is something I really simply recognize from the unit circle. So again, where do I see a y-coordinate of negative radical 2 over 2? At 5 pi over 4, I see negative radical 2 over 2 for the y-coordinate, and 7 pi over 4. So those are my two answers, 5 pi over 4 and 7 pi over 4. So again, don't panic. Even if it's something that's kind of weird, like even if it is cosecant of theta equals, 7. All right, don't panic. Sine of theta equals 1/7. Now, 1/7 is something that you don't see in the unit circle, so you're going to have to kind of treat it like the last set of problems. We're going to have to use your calculator and really draw a picture. But again, don't panic if you don't see a trig function that you like. Just use the reciprocals. All right. Now, the last thing we're going to look at in this video is that some problems are going to require that you do a little bit of solving. Okay, come on, I'm not asking that much. So again, this says 2 sine of x. Well, I don't really want 2 sine of x. I want sine of x. So again, I'm almost treating the trig function like it's its own variable. All you got to do is solve for sine of x. So I'm going to divide both sides by 2. I get sine of x equals 1/2. Now I'm ready to go. So what, it took me one step? All right, kind of not that big of a deal. Now again, remember, sine is a y-coordinate from the unit circle. So I'm going to pull out my unit circle. Where do I see a sine value? Where do I see a y-coordinate of 1/2? Pi over 6 and 5 pi over 6. So my two answers are pi over 6 and 5 pi over 6. Remember, I am still asking for answers in the unit circle, 0 to 2 pi. All right, now what about this next one here? Well, again, I see 2 sines, but again, it's still one trig function. So check this out. I'm just going to, remember, treat the trig functions almost like variables. I don't want this over here, so I'm going to subtract a sine of x from both sides. So I get radical 2 equals -2 sine of x, right? Negative w minus w is -2w, so negative sine minus sine is -2 sine. And then again, I still got one more step left. I want sine of x, right? I want sine of x. So I'm going to divide both sides by -2, and I get negative radical 2 over 2 equals sine of x. Once again, that's something that I easily recognize from the unit circle. Sine is the y-coordinate, so where do I see a y-coordinate of negative radical 2 over 2? Well, I see it at 5 pi over 4 and 7 pi over 4. In fact, we saw a problem like this a moment ago. So 5 pi over 4, and again at 7 pi over 4. Again, I'm listing all answers on the unit circle that I could see from 0 to 2 pi. So again, some problems do require a little bit of solving. All right, last one of the video here, and this one's going to require a little bit of solving, and something kind of extra cool is going to happen. All right, so again, I'm trying to solve for tangent. So the first thing I'm going to do is add the 1. 3 tangent squared equals 1. Divide by 3. Tangent squared equals 1/3. But I don't want that square there either. I want tangent. So how do you get rid of a square? Take a square root, right? I'm solving. Use solving techniques, guys. Come on. Now, here's where the only thing I run into a problem. Remember, anytime you take a square root in a solving problem, you got to consider that the answer could be positive or negative. Now, what's the square root of 1? 1. Square root of 3 is the square root of 3. So this means I'm not just looking for one answer. I'm looking for positive or negative. But once again, I don't like square roots in denominators, so I'm going to multiply by radical 3. So I get tangent of x equals positive or negative radical 3 over 3. Good news is I recognize radical 3 over 3 from my unit circle. Bad news is I have to list a lot of answers because I'm looking for anywhere where I see a positive or a negative radical 3 over 3. So once again, I really hope you guys listened to me and you wrote the tangents as you go around your unit circle. It'll just save you lots of time. All right, the first place this happens is at pi over 6. At pi over 6, the tangent value is positive radical 3 over 3. It then happens again at 7 pi over 6. At 7 pi over 6, y divided by x, if you do the math, you get positive radical 3 over 3. But remember, there's a plus or minus sign. So that means 5 pi over 6 is another solution, because at 5 pi over 6, tangent is negative radical 3 over 3. And again, it also happens at 11 pi over 6. I get negative radical 3 over 3. So because I had the plus or minus, there's actually 4 answers on the unit circle where I see tangent is either positive radical 3 over 3 or negative radical 3 over 3. So this is going to create a lot of answers. Pi over 6, 5 pi over 6, and I already forgot what the other one was. 7 pi over 6, and 11 pi over 6. So all of these are answers on the unit circle. Now again, the other thing I want to show you to end this video is the best thing about any solving problem is you can always check your work. For example, let me just confirm that 5 pi over 6 is correct. Now make sure you're in radian mode because 5 pi over 6 is radians. I'm going to type in tangent of 5 pi over 6, and I get negative 0.577, but let's just confirm that negative radical 3 over 3, bingo, that is correct. So now I can check the rest of them. Tangent of, let's do pi over 6. Now this time I get positive 0.577, but remember, I was looking for either positive or negative solutions. So again, you could easily use your calculator to check your work. It kind of makes it pretty nice. And again, this could be for any problem. Just make sure you're in radian mode if you're going to use radians. All right, that's it for part 1. I consider the problems that we discussed today fairly easy, but there's a little bit of a learning curve there to understanding what I'm doing. The next video will be over some slightly more difficult problems where we just have a couple more things to do before we get to the point where things are, again, really easy. All right, see you in that next video.